So welcome everyone to our CCNA1 class for today. I'm going to show you real quickly, once you get certified to teach the courses, you're going to have access to the following items. So under resources, course resources, if you go to the course you're looking for information on, so Introduction to Networks, and then of course we are doing English version 7.2, click there. You'll see all the different resources. Now if you go into 7.02, you'll see the activity source files, instructor source files, PowerPoints for 7.02. So if you wanted to know the answers to all the packet tracers, you can click on this source file, download it, open it up, and then all of your packet tracers are in here with the answers. Now please never give these to the students, because if you do, you're basically just giving away our answers to everything. So go back in here. So the one I was showing you was, I believe, 10.4.
10.43.
10.43.
Yeah, thanks, Kelly. I had forgot about that document.
Yeah, it's very useful because you do have access to all of these here. And so if you have a question about the answers, you can always go in here and look. And it basically is telling you where the stuff is going on, that you've got different information in here than what was being asked for in the actual lab. So the rest of you who are not yet accredited, you will not have access to this. You have to be fully accredited in order to be able to get access to these course files. So, but as soon as you're accredited for this class, when you complete it successfully, you will be good to go. By the way, I have very good news. I don't even think Brian and Michael know this. I was informed today that our college president has put the money forward to help us with our ITC classes going forward in the fall and in the future. We are going to have enough money for everyone in the CCNA1 class who was part of our grant in the summer to take CCNA2 if they so wish to for free. So yes, that money is available.
Awesome.
Yeah, it is very, very awesome. I was quite shocked because I didn't even ask for it, and our president has basically put a pretty large sum of money. Brian and Michael, I'll tell you about it after class here, but they put a very substantial sum of money forward for our ITC classes. So the good news is you will be covered. What I hope to do then is to shame Cisco and other vendors into also providing more money so we can provide other classes for instructors also. But that's the good news. If you are interested right now, all you got to do is keep working on CCNA1. The opportunity will be available for anybody who finishes CCNA1. Our next round of classes begin on September 8th. Go to www.stanley.edu. Stanley.edu. And if you go to future students, future hover ASC ITC, let me hover over it because I have to do it like this. Future students, ASC ITC. You can always find our schedule by going under ITC and our class schedule. So these are the courses we have coming up in the fall. They start September 8th, run through December 8th. And all of you will be available to take CCNA2 for free. And then hopefully we'll save enough money out of this to make sure that all of you can get CCNA3 in the spring also. That way everybody will be good to go, and we'll have that available for them. So any questions on that before we keep going on? All right. Well, my understanding is, by the way, Argentina was awesome. It was highs in the 50s, lows in the 40s and 30s. Very, very, very good dove and duck hunting. So if you ever want to go down there, I strongly recommend it. Four Seasons Outdoors Lodge is really good. So I do greatly recommend it. Brian and Brandon, my understanding is they went over basic subnetting, what we call classical subnetting, which is where you end up with the same subnets on all of your different links. So in other words, you're always going to have the same slash notation. So we're going to go back and use the 7 holy steps right here to real quickly do this particular item. Can everybody see my network here of three routers, and this really should be a, instead of a PC, it should be a switch out here. Can everybody see my document that I've got pulled up?
Yes.
Okay. So we got a switch here, we got a little PC down here, And what we're going to start out with, we're going to start out doing standard subnetting with the 7 holy steps. By the way, I come up with the 7 holy steps while taking a shower one morning, don't ask. And I was thinking about how we could easily make a way for non-math majors to do subnetting. And these 7 steps just happen to work. So step number 1 is what? Somebody tell me what step number 1 is. Maybe you didn't learn the 7 holy steps of subnetting. Step number 1 is determine the number of subnets that are needed. Now, there's a couple ways that can happen. One, I can just give it to you, say you need 50 subnets. Or I can hand you a diagram like this and say how many subnets are needed. So how many subnets are needed in this network right here?
4.
4, okay? So here's what we got. We got this subnet right here. We've got a shared subnet right here, a shared subnet right here, and a shared subnet right here, okay? Now, so we know that we need 4 subnets. Step number 2 is to write out the host bits. Now, your major network is this 192.168.12.0/24. So how many host bits do you have?
8.
You have 8 host bits, so let's write them out. 2, 3, 4, 5, 6, 7, 8. So we have 8 host bits. The reason I make my students write these out, especially early in the process, is so that they learn that in order to get subnets, we're having to reduce the number of hosts because we're borrowing host bits to get network bits. Step number 3 is use the formula 2 to the n equals the number of subnets. Okay? So, number of subnets. So, what power do we have to raise 2 to in order to get at least 4 subnets?
2 to the 2.
2 to the 2. So, n is going to equal 2. Step number 4, turn on the number of bits that you borrowed starting from the left-hand side, okay? And then find the value, the decimal value of that. So if we borrow 2 bits, we'll go 1, 1. And that is what value in decimal? 128 plus 64 is?
192.
192.
192. Okay, so now step 5 is we get our new subnet mask. So we take our old mask, which was 255.255.255, and we add our new value in the 4th octet to it, 192. So our mask now is going to be 192. So /26, for now /26. Step 6, we need to find our magic number or our variable in each individual octet. Now, we've only borrowed information from the 4th octet in this instance. So to get this value, we go back to step 4 and we find the highest order bit left turned on and find its value. So what is that? 64, right? So our variable, or what some people call the magic number, is going to be 64. We then can come over here and actually do our subnet. So it's going to be 192.168.12.0 to 63. Then it's going to be 64 to, what's it go to next?
127.
127. And then we got 128. Oop, that's an 8. Sorry about that. 128 to 191. And then we got 192.
255.
255. And on all of these, the new mask is /26. Okay. So at this point, I could come in here and say, right here, I'm going to use the address 192.168.12.1/26. And then everything on this subnet would have to be from .2 to .62. Why can I not use 0?
Network address.
It's a network address. All your host bits on these items on the left-hand side, these numbers are your host bits are all zeros. On the right-hand side, your host bits are all ones. So you can't use 0 because that's your network ID. Can't use the last one because that's your broadcast ID. So I could assign to host on this subnet on my left here any number from .1 to .62. Now right here I would put .65/26 and .66/26, and then I would do .129/26, .130/26. Sorry, that's a bad 30, but it is a 30 there. And then over here I would do .193/26. Now, what's the problem right here? What have I done right here? This will work, by the way, all day long. You could build this network and it would work all day long. You would have no issues with it. But what is the problem with that link between those two routers right there?
Wastage of IP address?
It's a huge waste. Because, by the way, how many IP addresses are there available on each one of these subnets? Do you remember the formula, or did they give you the formula?
62.
The formula to determine any time the number of hosts on a network or a subnet is 2 to the h minus 2 equals the number of hosts. Okay.
64.
Okay. So let's look at this. So it's 2 to the 1, 2, 3, 4, 5, 6 power, which is 64, right? What's 2 to the 6th?
Yes.
Okay, so 2 to the 6th minus 2 equals 62 usable hosts. Now there's 64 actual addresses in each one, but remember, the first address is your network ID, the last address is your broadcast ID. So that's why you subtract 2. If you ever wonder where that subtract 2 came from, that is why. So with standard subnetting, while it is great, it works. It's called classful subnetting, by the way, because everything has the same mask on it. All right. And also classful means if you have a classful routing protocol, it means that it does not carry the subnet mask information in its route table updates. It assumes that the mask is the same across all interfaces. It's good, but it's wasteful. So we need a way to fix this. So let's fix this. Let's go back and let's fix this. So how are we going to fix this, everyone?
VLSM.
We're going to use VLSM, exactly. So what we're going to do now is we're going to create the same network, but we're going to make it a whole lot better. We're going to be more and now what we're going to do is this. We're going to assume, let's just say, for whatever reason, let's say there's 60 hosts here. Okay. Let's say there's 30 hosts here. And then how many hosts are there right here in this one? On this network right here, how many hosts are there?
2.
There's only 2 hosts. By the way, Tom, are you going to the North Carolina meeting this week? Up in Winston-Salem?
Yes, sir, I am. But I'm actually going, I don't know that I'll be, I'm supposed to go, I'm starting a new job the 1st of August.
Gotcha.
I'm starting a CIMC job, so I don't know if I'll be able to attend the networking session or not.
Okay, that's not a problem. I will be there though. Anybody that's in North Carolina that's a teacher, I will be there on to Wednesday afternoon at 2 o'clock doing a presentation. So I will not be in class Wednesday afternoon. So
All right, I may try to drop by and talk to you.
okay, no problem. So now let's look at this let's use VLSM now. So when we use VLSM, what we end up doing is really, we just subnet a subnet. So we take this one major network, which is, what kind of class of address is this, by the way? This is a class C, because it begins with 192. All right. And we're going to just take it and borrow 1 bit from it. So we're at /24. We're going to go to /25. What would be your variable or magic number if you were at /25?
128.
128. So we take this network here and we break it into 0 to 127 and 128 to 190. To 2. Hold on. Let me get where's my stuff here? Yeah, I gotta get my stuff. My eraser. Okay, get rid of this. My eraser and erase here. To 255. To 255. Okay. Now, we need 60 hosts. Right now, how many hosts are there on the /25 subnets? What's our formula, folks? 2 to the 7th minus 2 equals, there should be 126 usable hosts on each of these two subnets. Do we have any network that needs 126 hosts?
No.
Not in this diagram. Now, real world versus book world. Real world, I'll probably go ahead and pull this network out right here to use for the 60 hosts. Anybody know why?
Growth.
Growth. Hosts are like rabbits. Today you got 2, tomorrow you got 10. So, oh, by the way, Argentinian rabbits are huge. I mean, they're as big as a dog. And you think I'm kidding you, but I am not joking. Their hairs are as big as dogs. It's amazing. So, but this is not the real world. We're in the book world right now, so we are not going to do that. We're going to do it as close to the requirements as needed. And if you're taking the test, you do it as close to the requirement as needed unless it tells you to allow for X amount of growth. Okay? So what we would do then is we will borrow one more bit to a /26. Now what's our magic number at /26?
64.
64. So we'll break this into 0 to 63 and 64 to 127. And then we'll break this one into 128 to 191 and 192 to 255. Now the curriculum would then have you do the following. The curriculum would have you grab this right here and put it on this network right here. I don't do that in the real world, and I'm going to show you why in a second. Okay? Real world, this is what I do. I, personally, and this is what I do, and this is why you have to be careful when your students do these labs, because they can do it correctly and get no points for it because they do it the way you do in the real world versus the way the book teaches. Real world, I would pull this one out right here. And so I come up here, and this network would be the 192.168.12.192/26 network. Okay? And then I would have put 1.193 here, and then every address from 193 to 254 could then be placed on host. Okay? Now, at that point, that network is gone. This network is no longer available. You can't use it again, so it's been pulled out.
Kelly,
Yes, sir.
can you explain why you would use that last one? Question number 1. Question number 2, what would they require us to do on the actual certification exam?
On the cert exam, they're going to give you very specific information about which one to use. They're going to say use the first one for your 60 host. The second one for you. On the exam, they have to be very, very clear as to what they ask you to do. So you don't have to worry about that on the exam. You're not going to have any problems with that. Okay?
Okay.
Okay. The
Thank you.
curriculum assumes you're always going to pull it out of this first range for your biggest network. All right. Here's why I don't pull it from there. On these links of 2 hosts, let me go ahead and subnet on out. I'm going to subnet out this /26 here real quickly for you. Okay, so here's /26. We'll go one more, /27. What's our magic number there?
32.
32. So 0 to 31 and 32 to 63. Now this is a network of 30 hosts. So now I'm going to pull this out right here. Okay, and this goes here as the 192.168.12.32/27. Okay. Then I'm going to do a /28, and this is going to answer your question in just a second, Tom. 0 to 15, 16 to 31, /29. We're going to break it out 0 to 7, 8 to 15, And then /30 gives us 0 to 3 and 4 to 7. And by the way, you can also break this out to 8 to 11 and 12 to 15. The reason, sorry about that, 12 to 15. Let me fix this. I got to get rid of some stuff here because I got it too close to the edge. So 12 to 15. I can write with my finger. Okay. So 12 to 15. Now, the reason I do this is so that I can put the .0 network here, /30. The .4 network here, /30. So this would be .1, .2, .5, .6. I do that so that all of my /30s are 0, 4, 8, 12, 16, 20, and then they're not some crazy number up here. And then that just makes it simpler for troubleshooting. That I know all of my point-to-point links are .0, .4, .8, .12, .16. So I try to keep them in this first range here of the 30s. That's the only reason, Tom, and that's personal preference. Some companies put their point-to-point links down here. They put them on the very bottom. They put them down here in this bottom. But almost 99% of the companies I've seen put their point-to-point links in that .0, .4, .8, .12, .16, just for simplicity's sake. Okay?
Okay, thank you.
Yeah. Other questions about that? Now let me show you a little trick here. Let me show you something. If I can get this to move over. We have used this .0 and .4, right? So we use this network right here. So we use these two /30s right here, .0, .4. Well, guess what that means? That means this is no longer available for use. This is no longer available for use. This is no longer available for use, and I cannot use this. Why would that be? Why can I not come back and pull out this 0 to 63 to use somewhere if I've used the /30, 0, and .4? Can anybody tell me?
It's on the same subnet?
Nope. If you do that, it's overlapping. Notice the address is 0, 1, 2, 3, 4, 5, 6. They're all in here. They're already in this range, but we've assigned them. We've used them. So we can't use them again. We can't go backwards. Now the good news though with VLSM, guess what? I could use this network right here. I could use this /28 because none of my addresses that I have pulled out have been used from there. I could use this 64 to 127 and I could use this 128 to 191. Both of these are still available. So this VLSM allows us to subnet a subnet, and it also allows us to better use our addresses in a more economical fashion. Questions? Has anybody been monitoring chat? I haven't been looking at it. Ryan or Michael?
Yes,
Yeah.
Eddie.
Yeah.
Yes, Eddie, the last thing that was put in there was Eddie. He answered your question about the overlap.
Yep, it overlaps, so you can't use it. And in fact, if you tried to use these on the same router, it would tell you that you had overlapping address spaces. So the router itself will try to tell you. So if you tried to apply the .0 on, let's say, let me show you. If you tried to put this .0 on this router A here, and then also tried to put this 0 to 63 as /26 right here, it would have told you can't do it overlapping. Okay? So, VLSM, Variable Subnet Masking, is called classless because it doesn't care about the class. It doesn't all have to have the same masking. You'll notice we got a /26, we got a /27, and we got two /30s. But it allows us to use the networks in the way that are best for our particular designs. Okay, questions? Michael? Brian? What you got? Any ideas? Anything you want to see? Here's another example here when you can look at doing multiple IP addresses. You'll notice they're using a slash 172.16.00/22, and then they're using that. They're just breaking it out and pulling out the pieces that they need to get these subnets that they need to match their schemes. So it doesn't have to be something that's along a classful boundary. So this could be 172.16.00/16, but they did a /22, and then they're just building out from there. And you'll notice they did for the networks that needed a /26, they put out /26s, and then they went on down through there. And if they need more, then they can borrow more to give them different addresses. Now in this case, they used all /26s, but you also can do it to where you have true VLSM. Here's a video on it. We're not going to watch the video. Hopefully you've watched those. But this is the same type of concept where we just go in and design our network. If we need 25, 20, 15, 28, you'll notice what they do is they pull their 28 out first. Okay, so they did all the ones for 28. So they did the .0 and all. And then their site to sites, they've got some weird addresses they'll end up with, pretty weird on these /27s. This is trying to use non-VLSM, and then going into VLSM here. Here it is. Trying to go into VLSM, you notice they're using the /30s. They use this for the networks, and then the WAN links. Up here, you'll notice their WAN links that they want to use is 224, which means your address is 225 and 226, and then 228, 229, That's a pain to run to me. I just like 0, 4, and then you got 1, 2, 5, 6, and so on and so forth. They did exactly what I just did. They just used it, and they subnetted that network, and then subnetted subnets to get what they needed. So here you go with their setup. And you see how weird this is. Again, when you look at this, you can see how you've got this weird 225, 226, which is not really weird, but it's not as intuitive as .1, .2, .4, .5, .6, .9, .10, in my personal experience. Michael, you've worked out in the real world. What did you normally see on your point-to-point WAN links?
On our point-to-point, we usually had /30s.
Yeah, and you started at the bottom with .0, .4, .8, whenever you could.
Usually when we addressed our routers and switches, a lot of times we would skip the first couple of addresses. So we may start out with .10 for the gateway. And but most time we did start out from the top, but we would just skip a first couple and then we would skip a couple also between devices. So if our router was .10, our switch may be .13, and then we would leave space for printers, because anything that we statically assign, we would leave an address space for those, so they will all be in the same little area and everything.
Okay. Now, one of the things that you got to be careful about is you got to be careful again that you do leave room for growth and that you have growth. There's a lot of information about that. They don't really talk about it a great deal in the curriculum, but you do need to be aware of it and need to keep an eye out for it.
Yeah, that was also one of the issues we had a lot, where a clinic, we would stand up a clinic or a medical facility. In the beginning, they may say they're only going to have 50 devices total. Then in about 6 months, they have 150. So we had to go back in and try to carve out space to make a bigger subnet for them in order to do that.
So a lot of times you're better off just going ahead and saying, hey, I'm going to make a bigger space than normal.
Yeah, we ended up usually using an address space where we would leave at least 50 or so addresses just in case.
Very good idea. Very good idea. All right. Any questions? Any questions on that? Just remember, if you have one rabbit today, you'll have 10 tomorrow. So here's an Argentinian rabbit, or at least one of their hairs that exists. So be aware that, now I don't believe that's a real rabbit, but the one I saw was honestly about that big. It was as big as a dog, which blew my mind.
Do they hunt them down there?
They will shoot them if they get a chance because they're good eating. So we didn't get a chance to hunt them, but they were down there. They ran across the field, and the guy I was with who didn't speak any English was going, Rabito, and I looked at it and I said, there's no way that's a rabbit. I said, that's a dog. And he said, no, that's a rabbit. And I was like, you've got to be kidding me. So yeah, they're massive.
Kelly, while you're doing the lecture, I've been catching up on grading. One thing to bring up, still got a lot of stuff that hadn't been submitted by individuals in the class. So if you're behind on something, please look at getting it caught up. The class is coming to an end, less than a month now. So,
I'm in class, kinda. Sorry. Yeah, we've got till August 14th. So classes are getting down to the last month. A little under a month now. Michael has turned on the final written exam for you if you want to take it, and it will be on from here on out. It's on every 7 days. Don't forget that you need to do the course feedback first before you do that. And then we will be doing, like I said, we'll be continuing lectures and everything out through the 14th. But you should be getting into this part of the course now where you're at least up into 11, 12, 13. So you're getting closer to being finished so you can get finished up. Don't forget, too, that you must do the hands-on final in NetAcad. Not NetAcad, in NetLabs. So if I go to NetLabs, I'm going to show you the hands-on exam for this class. So if you log into NetLabs, which for you, it's going to be your full Stanley email address, and then whatever your password happens to be for yours.
And Kelly, Michael was asking a question, when was the last day the final exam can be submitted?
It would be on the 14th. Right now, that's our plan, to try to have everybody done by the 14th if possible. If we don't have everybody done by the 14th, we've got a little bit of leeway because the next set of classes starts September 8th. But the more of you that, if we can get everybody done by the 14th, it really makes life easier on us because we are running some classes through the Navy that we need to be available for during that time frame. But if I do a schedule lab for myself, folks, and I go to our class, you'll notice that there's a CCNA 1 version 7 skills assessment. Click there and schedule it just like normal. You cannot preview this because it is the, you can't. But you click right here and pick yourself a pod, and pod 2 is still offline, I see. Need to get that one back on. And then just give yourself a time frame that you're going to take it. I must have clicked off somewhere here to get, there it is. So just do it like normal. It's just a normal lab. And then give yourself, I would schedule at least 4 hours, even though you probably will not need that. All right. But it's just another lab inside of there called Skills Assessment, or SA. So that is your hands-on final exam. When you do the hands-on exam, there's a couple different networks you can use as part of the item. You should use the very first IP address range to do your subnetting on. And you'll know what that means when you look at it, when you look at the skills assessment itself. In fact, here in just a moment, I'm going to turn off recording or pause recording, and I will show you that so you can see what I'm talking about. So everyone that's here, I'm going to actually pause the recording. Okay, so now we're back after I have shown the hands-on exam. Okay, now, any other questions? Y'all haven't gone over IPv6 addressing yet, have you, Michael?
no, have not.
No, not yet.
We can do that Wednesday if you want us to.
Yeah, why don't y'all do that on Wednesday, go over IPv6. I will tell y'all folks about the CCNA. One of the big things that really is important about IPv6 is to understand how IP addresses can be assigned in terms of SLAC, stateless address auto configuration, and then also SLAC with stateless DHCP, and then SLAC with stateful DHCP. And all of that is covered in this particular section here. So know that and you'll be good. I will tell you this is an interesting thing. The reason we need IPv6 is because we have no more IPv4 addresses. They're done. They're completely done. They have been done for some time. They've been done in the U.S. since July of 2015. So for 7 years, we have been out of any new IPv4 addresses. Does anybody know how we've been able to keep the internet running in the United States?
Is it NAT?
It's NAT. Yep, that's the only way we've been able to do it is by using private addresses, using those private address spaces in RFC 1918 and doing NAT. In fact, in parts of India, they're actually doing NAT 6 or 7 layers deep. In other words, the actual IP address is being NATed 7 different times before it gets to a public address. Okay. Now, the beauty of IPv6 is this. Guess how many IP addresses there are in IPv6? This is what they say. They say it's enough to give an IP address to every grain of sand on the entire planet. So it's a big address space. I mean, a really big address space. So Brian and Michael will go over IPv6 and how we can look at dual stack versus single stack and customization on those. But IPv6 is really not as hard as what you think it is. In fact, I think once you get to looking at it, you will realize that it's really simple. It's just a lot of typing. And I do think we will end up with keyboards that have little hex keypads on them as we move forward, especially for network engineers, because that way they'll be able to put in IPv6 addresses quicker. Yeah, Dr. Reynolds, you are correct. A ton. Yeah, that is definitely true. And you know what's funny? You know, it's 340 undecillion addresses. And we think, you know, we once thought we'd never run out of IPv6 or IPv4 addresses. But, you know, when we get into a world where we have nanobots and every little nanobot has to have an IP address on it, who knows? We could very well easily end up with, you know, needing more than 340 undecillion. I will give you another little thing that's neat, folks. I got Starlink working. I did get Starlink finally, and I have been able to get it working at my house, and it's sitting in my front yard. I only have it on my roof yet. It's just been sitting in my front yard, and I've been getting somewhere between double to 8 times speeds down and about 3 to 4 times the speed up. So I'm getting between 30 to 80 megabits per second down and around 3 to 5 up, which for me where I'm out is just game changing. Because I have been in the range of literally 10 megabits per second down and less than a megabit per second up. So it's been really amazing to see what's going on with the low Earth orbit satellites. And by the way, here's something crazier. I'm getting response times in the 30 millisecond range. So I'm getting 30 milliseconds response times, which is insane. That's better than what I get on my wired connection through my DSL. All right, any questions for me? Any questions that you want answered about VLSM? Bring in questions. Yeah, it's better than Windstream, definitely, Dan, it is. Yeah, Starlink. Really, Mike, you got the same thing. Mike, you're in North Carolina, aren't you? Mike Peluso? Are you in North Carolina? I know they just opened up parts of North. Okay, yes, Mike says yes. They just opened up parts of North Carolina, like me, to be able to get Starlink. So it's slowly rolling out in NC. There's not. They originally had it a great deal to the west, out toward the coast, because there was so little internet access out there, and also up in the mountains. Dan's in Clayton, Georgia. Yeah, and you got it, Dan. Dan Insman. You got Starlink.
Hey, Kelly.
Okay.
Kelly.
Yeah. What you got?
Could you kind of go over what Starlink is? I know
Yeah.
Michael Reynolds wasn't familiar with it.
Yeah. Let me put it in here. This is. Let's see if I can get it. Okay. So SpaceX has created a low Earth orbit, or LEO, is what it's called. LEO satellite system, and basically this is what you get. You get this receiver. By the way, it moves on its own, so don't be stupid like me and try to get it to move without turning it on. I thought you had to actually move it yourself. No, it moves itself. But this on the right here, this is your modem that ships with it, and it's a wireless modem. And then it literally ships with these 3 devices and a cable. and you plug it in, and I sat at my front yard, and literally, I had this thing up and running in 5 minutes. It was that fast. Now, I've got to do a whole lot of work to make it coexist with my existing network in my house, and still it's not going to be a whole lot of work, but I had to order this. Unfortunately, this modem doesn't have an Ethernet connection on it. You have to buy a special Ethernet adapter from Starlink that's like $49. So there's a little bit of the Apple stuff on that in terms you got to buy their stuff. But this satellite sits in your yard or up on your house, and it actually pulls most of its signals from the north because the Satellite Constellation is to the north. And so it is expensive. It's $600. It was cheaper than this when I bought mine. It was like $550. But it's $600 for the hardware and then $110 a month. But for people like me who have had almost no internet that's worth using, this is a great possible way, especially if you can get yourself a good place to actually set it up. A lot of at Cisco Live, we had a lot of companies talking about this Starlink for business, especially construction companies and companies that are doing things like, I'll show that too, Mike. Construction companies or mining companies that are doing things. So let me show you the Satellite Constellation. Let me see if I can get this right. It's Starlink. SX. I think that's it. Starlink SX. Starlink coverage tracker. Yep, just educational. We know this. Thank you very much. Show it to us. And so what it shows is it's showing you the current satellites that are over where they're at. So these are the satellites in their current orbits. And so you'll notice there's not a great deal of coverage right now in sub-Saharan Africa or even in the southern. Almost all the constellation right now is built for the northern part of the United States, or actually northern part of the world. But you can get all kind of crazy things. Orbital plane status, you can see, but it's showing you the satellites, and you can actually see where they're at. Look at the latency on some of these things. And what's even cooler, they just started putting out new satellites that can use point-to-point lasers on the satellites themselves to hand off your signal. So imagine, of course, the signal has to go from your ground station up to a satellite and then back down to a ground station. But imagine if I was trying to hit satellite number 3, but satellite number 3 went past my viewing in my particular yard, but I could still see satellite number 1. Satellite 3, instead of sending it down to the ground station, could send it by direct link. And because it's in space and it's doing it at speed of light, the milliseconds are up. It's almost no latency whatsoever. It could send it over to satellite 1 and drop it down to a station, or satellite 3 could send it to 9 and drop it down to a station. So it is really cool. I mean, it's one of the coolest things. And they keep sending more and more satellites up. In fact, they've got now probably about, I think almost, well, you can see, they've got 1,711 operational satellites. 2,092 are in orbit. So 381 are standby. So they've still got a good number that have not yet been brought into fully functional operational status. And as they do it, you'll get more and more capability. So it's pretty nuts. It really is. It's amazing. And it's the reason it works with these low latencies is because the satellites are not very high. I think they're most like 500 kilometers up. But that's what Starlink is. It is a satellite-based internet service that is finally fulfilling the promise of it, instead of some of the others like HughesNet and all that are actually slow and have high latency. These are actually fast with low latency. It's not cheap, but again, it's one of those things where some places in the world that literally would never have internet access before, or before now, are finally going to have it. So. Yeah, and there's a lot of stuff here talking about the safety of because there's a lot of people worried about the safety of Here is the current places you can get it, and so you can see availability and coming soon. So you can see, in North Carolina, there's a wait list, and actually they don't even show that my area has it yet, but they're starting to slowly fill in these areas. You'll notice that it was on the coast mainly, but they're really starting to fill it in. You'll notice that most of it was in the west and north into Canada. But now we're doing, they're slowly starting to fill in down here inside of our areas. So, thank goodness. So, hope that
I could
answers.
see this being used in educational communities also, especially those communities that don't hardly have any internet access at all.
Yeah, well, Matt, one of the things Starlink has done is they have a lot of projects with indigenous groups. So on Indian reservations and both indigenous, up here in Manitoba, up in northern Canada, where there's no internet access, now they can put one of these in, and the school can have access to everything that's on the internet. A lot of the reservations are doing this. They're putting this in because there's terrible internet connectivity to the reservation, but this gives them internet connectivity is as fast as anybody else. Yeah. So that's the amazing thing. And I think eventually you will see it, some areas, for instance, I mean, if you lived in New York, you can probably get, you can grab a connection via probably a cable or actually using fiber optic. But for the majority of the people in the United States, we have learned that we don't have fast enough internet. And this is going to finally help with some of that, I do believe.
Hey, Kelly,
Yes, sir.
does this solve the problem of VPN configurations? Because wasn't the old satellite, because of the uplink and downlink time and the latency,
Yeah,
you couldn't get VPN connections?
it could cause VPN connections to fail. VPNs work fine over this. I've already used it to connect to our network here at school. Because of the low latency and high speeds, VPNs work perfectly fine over Starlink. Yeah.
Okay.
Yeah. So if you have really slow internet and you have a decent view of the northern sky, and I will tell you that is important. If you're surrounded by trees and can't get above the trees, you are going to have issues. So just make sure that you are able to have a decent view of the northern sky, and this may be a possibility for you. So, all right, everyone, I'm going to stop sharing and I'm going to stop recording. I've done my Starlink. They ought to give me a break because I just did my Starlink commercial for them. But I'm going to